I promise not to be too macabre here. Actually have a great speech today by our very own club president and area governor, Jeff Chilson. In our daily lives, we're all aware of abstract concepts. Some of us in the power business, it's reactive power. Still can't wrap my mind around that. Einstein's theory of relativity is one of those abstract things. Then there's always the male psyche. It's kind of out there. Today, Jeff will be completing project number 5 from the Speaking to Inform manual, which is the abstract concept. Carl, can we please have the green card at 6, the yellow card at 7, and the red card at 8, or the pumpkin card at 8. And please join me in welcoming Jeff Chilson to the podium with his speech, Aurora, the Mystery Explained.
There are ghosts in the North Woods. Or perhaps they're distant campfires from some mysterious people. Or the reflections off the armor of warriors as they make their way into the afterlife. The Northern Lights have inspired legends and aroused awe. Even in our modern society, it's only been in the last half-century that we've started to figure out this mix of conditions that puts together the aurora. And that's what impresses me when I've read about it. It's this interesting recipe of astronomy and chemistry and physics. So today, let me take you on a journey as you cross the powers of 10 and unravel the mystery that is the aurora. And it all starts with the sun. Now the sun, as it produces its light, spits out into the solar system a bunch of highly charged particles, electrons and protons. We call that the solar wind. Now every now and then, the sun, in its constant state of flux, has these concentrated areas of magnetic activity. And these will cause the sun to spew out even more particles into the atmosphere, or into the solar system. We call those events coronal mass ejections, or CMEs for short. Now it's very important to note that the sun has a regular activity cycle for creating sunspots, which are associated with these coronal mass ejections. And it's roughly about an 11-year cycle. And right at this moment, this year, we're in one of those periods of predicted maximum activity for sunspots to occur. So we should start to see a little bit more auroral activity start to happen on our planet. Speaking of the planet, though, as that solar wind spreads out across the solar system, that's when it encounters the Earth on its orbit. Now, to the solar wind, the Earth looks just like a giant magnet. That's pretty much what it is. Now, if you were in elementary school and you sprinkled a bunch of iron filings onto a bar magnet, you got to see those magnetic field lines. The Earth looks exactly the same way out in space. It has this huge magnetic region we call the magnetosphere. And for the most part, that magnetosphere protects us from being bombarded by all these particles out in space, hitting the areas that we live in. But those magnetic field lines will have the tendency to trap some of that solar wind and funnel it towards the north and the south magnetic poles, where there's always a little bit of auroral activity going on. Now there's a little bit of a witch's brew here that kind of goes on. And that's part that they really don't quite have a good understanding of. But it's when they have this coronal mass ejection, puts an additional concentration of electrons and protons up in the upper atmosphere. And we call that the ionosphere. Out there is already a large concentration of charged particles. And now when the magnetic lines start to align even more tightly, it causes something like a short circuit. And all of a sudden there's this huge influx of charged particles down into the atmosphere. And it's those auroral ovals that will start to spread further to the south from the north, and then up from the bottom of the Earth towards the equator. And folks like us will start to see more auroral activity. Now it's when those particles come raining down through the atmosphere that they encounter the atom. This is one of the most exciting parts that I always think about. When those particles start to strike an atom, they'll impart a little bit of energy to it. What happens is, we say that in chemistry, it goes from a ground state to an excited state. And then, as the atom starts to shift back down towards its ground state, it returns to its it loses some of its energy. But we know that energy is conserved, and so the energy translated from that collision of the electron gets sent out in the form of light. Now, if the electrons strike an oxygen atom and moves it to its excited state, when that oxygen returns to its ground state, typically it will release green light. And there are some instances when, if it has a little bit more time, and that, once again, that oxygen will kind of shift down, it has maybe a little bit less energy in it, it'll instead release a little bit of red light. Now, green is the most prevalent one that we tend to see, but under periods of very high activity, when even more particles start to stream down further into the atmosphere, it encounters more and more nitrogen. And nitrogen, when it moves from that excited state down to its ground state, can release as many as 4 different shades of red light. The other color we typically see in high periods of auroral activity is, you'll see a little bit of yellow. What happens there is you get this mix between the green band and the red band. You get a little bit of an interference pattern intermixing, creates a slight yellow glow between the two. There are other colors that are possible: purple, pink, blue, but often those are very rare and quite faint. Particularly down here where we have a lot of light pollution, they're very hard to pick up with the human eye. But that is the aurora. From the sun to the earth, from the earth down to the atom, from the atom to your backyard. It's this wondrous concert of the largest objects in our cosmos down to the very tiniest. And it creates a display that has inspired generations. And I hope in this season, the sun's activity, that we'll be able to experience and see these mysterious lights very soon. Madame Rend High Witch.